Okay. So let me share my screen as well. Okay. Are you guys seeing my screen?
Yes, sir.
Yes, sir.
Okay. Okay. So, how many of you have at least gone through this book? For
I
data
have
science?
gone through this once.
Okay, Parthi has gone.
I'm in the middle of Tibble's Brangle, kind of.
Okay, you're in the middle of Tibble's chapter 10, is it? Okay.
Sir, I have started, not
Okay.
completed it.
Yeah. Yeah, I'm sure that you guys at least have opened it once, no? I mean, I'm hopeful that you're not totally unfamiliar that, okay, what is this book? No? You guys have at least opened this website, right? It's free of
Yes, sir. Yes.
Yes, sir.
Yeah.
Yes, sir.
Yeah. There is a second version of this as well, but let us stick to this for now. The newer version, anyway. So this is a book by Hadley Bickup, and this is still a work in progress, as it says. That there is a second version, and it's supposed to be complete by early 2023. It's still, I think it's up now. Anyway, so if you go through this process of how he talks about data science, the goal of data science is to help you learn most important tools in R that will allow you to do data science. The way he puts it is that it's like a you try to import data, you tidy the data using the tidy data principles, and then you try to understand the data using this iterative process of asking questions and transforming and visualizing and modeling, and then come up with new questions, and then again you test those hypotheses. And once you do all of that, you communicate. Right? So I'm sure that these first two steps, importing the data and tidying the data, even though tidying the data is a little dicey, we have not worked on it too much. Must not be too comfortable with it now. But at least the base principles are clear. I just want to get your feedback on this. You know how to import data comfortably?
Yes, sir.
Okay. You know how to the tidy data principles, right? You know that, okay, all the columns are variables, all the rows are observations, and each cell has to have a value. And
Yes, sir.
why are we insisting on why you need to have tidy data and tidy principles? Is that because there are a set of tools that you can reuse again and again if your data is tidy, isn't it? I'd like to bring your attention to this analogy of ordering a chair or a table from IKEA online, and then just one tool is enough for you to do the whole process. You don't need a hammer, chisel, and all of that, isn't it? So yeah, but then I'd like to bring your attention to this other aspect of this whole iterative process. When we talked about transformation, it's the wrangling of data, because you're getting data in a form that is natural to work with and what feels very difficult at times. But visualization is fundamental, because in the sense that visualization is more human. Numbers and all or text and all computers can understand, but visualizing things actually sparks some kind of brain activity in your, some kind of connection happens in your brain when you look at something visually, and then inferences can be drawn. So it's fundamentally a human activity, and it not only helps you to understand the data, but it also helps you to form those questions, new questions. If you remember our session on exploratory data analysis, EDA, we were talking about question generation, right? One of the key things to exploring your data is to ask the right question. And the key to asking the right questions is asking a number of questions, right? So, and once you ask that question, those questions will be answered by you through different modalities. And one of those important tools is visualization. And this is a very important skill set. And if you remember, I've shared with you an article in the last session on why you should not use pie graphs or pie charts or things like that. But because when you're talking about visualization, a lot of things actually is very interpretative, in the sense that what you might interpret a graph as might be interpreted as something else, or the results might be something else when somebody else is interpreting it. But having said that, it also is important that as a researcher, your skills of how to interpret the graph correctly is also important, right? For example, I show you same graph, and MBBS student might interpret it differently. First year PG will be interpreting it differently. Third year just PG will be, or SR will be interpreting differently, or high level maybe associate professor might interpret it differently. So visualization are not just how to do the graphs and things. It's also interpreting things, and that's what we are trying to stress on. Does it make sense? Am I not making sense? Please stop me, because there is a lot of unnecessary feedback from outside. So I just want to ensure that I'm not only blabbering and you guys are getting through.
No,
Is
sir.
it clear? Yeah, great.
Clear.
So, okay.
Yes,
So
sir,
I'll
it's
just
clear.
quickly jump to this chapter, data visualization. And so again, we are, you all know John Tukey, right? John Tukey is the one who is considered to be father of exploratory data analysis. But he has written a lot of books, and lot of his teachings are taken as quotes, and Hadley likes to bring those quotes again and again. But he says that John Tukey says that a simple graph has brought more information to the data analysis mind than any other device. So visualization is the best way to understand the data. That's what he's trying to say. Because no matter how many good tables and statistics and p-values you give, simple enough plot or a graph can make all that things clear in just 0 words. You get my point? So it's very important that you take visualization seriously. When I say seriously, I don't mean that you take a very hardcore stand on it and things like that. I mean, when I say take visualization seriously, I mean to say that it is as important as any other statistical test, chi-square, p-value, p-test. That is all secondary, right? But visualization is the one that is actually trying to make things clear for you as a researcher, and so that you can actually understand the data better and generate new questions and hypotheses and test those hypotheses. Again, to test those hypotheses, you can require visualization to actually see how things are. So again, this is just like we talked about the principles of tidy data. We are also going to talk about the principles of grammar of graphics. So grammar of graphics is a very coherent system that is built on how to build meaningful graphics, because there is n number of ways anybody can make graphs. You can draw it on a paper, you can use some other Adobe or some other way to, PowerPoint also you can make graphs. Excel also you can make graphs. You can make graphs using any other software, but then making those graphs reproducible is also important. And not just for others, it's also important to you, because if you have seen the last session that we had, just because we have written it in such a way, only thing we had to do was change the variable name, and then we very quickly came up with very quick graphical representation, right? Yeah, there are a lot of other parallel readings that he suggests. One is this layered grammar of graphics, which is not a very big resource. It's just a paper of, I think, 25 pages or something. This is a little boring, to be frank, but it gives you a lot of idea on what is actually going inside the grammar of graphics part, right? So, for example, every graph has n number of what do you call it, um, aesthetics, statistics, and uh, data, elements, legends. All of these are parts of a graph. So, for example, if you are looking at the way ggplot is built, you have the data or mapping, which is again, data is you take DF or your TB data set or whatever, which is a table again. And then the mapping says that, okay, this is the aesthetics of the graph. So X is this, Y is this, the color is this, or whatever. And then you can say that, okay, I want a geom point or a geom line or a geom bar. So that is the layer. And then you can give the scale and guide in the sense that, okay, when I say scale, it means the legend, basically. You can say, okay, my color is represented this way. So size of the plot, size of each of the point is representing this. The shape of the, the point, whichever is there, is represented. And then you can break it down according to the different age. Okay. Is the visuals clear? Is it pixelating, or is it clear?
Yes, it is clear. Yeah, now it's clear.
Okay, great.
Yes,
So when you have time, just go through this, layered grammar of graphics paper by, again, Hadley Wickham. This is relatively old, but then he talks about a lot of things which will get clear later on, right? Yeah. Anyway, so coming back to the book, so the package that is doing the background work is ggplot2. GG is grammar of graphics. Plot2 is, again, there's an analogy that it's not ggplot, it's ggplot2 because there's a lot of iterations that went into why it is called 2. So anyway, so when you load library tidyverse, it's ggplot that is already being loaded. You see, there are 8 packages that are already loaded with you, including tibble, tidyr, readr, for all of that, and ggplot as well. So the first set is that there is an inbuilt data set within ggplot, which is called the MPG data set. And I hope that you understand what I'm highlighting here. You understand what this is? So there is a function or something within this package called ggplot, and that is the 2 columns are actually helping you to retrieve it. And is that clear? We've used this mtcars dataset last time, right? Yes or no? Am I audible?
Yes,
yes, sir. Yes.
Okay. So this is MPG dataset. This is again 11 columns and 234 rows. And manufacturer, model, displacement, what is the year of manufacture, how many cylinders it has, what is the transmission, is it auto drive, and all of that. So to create a ggplot or create a plot using ggplot, you specify the data within, and the function is ggplot. The package is ggplot2, but the function is ggplot. Anything starts with ggplot. So you can either say ggplot bracket open data equals to mpg, or you can say mpg by ggplot. Okay, both are the same. Here you're specifying it explicitly that data is this. But one thing you need to understand is that within a ggplot, you can keep on adding different layers and elements and things. Like you are adding a geom point here, right? So ggplot is there. Which data set it is taking? It is taking the MPG data set. And what it is going to do with that MPG data set? It is going to create a geometry of point, right? And where is that point supposed to be? Okay, it is, you're mapping it now, and you're saying these are the aesthetics of that ggplot. You're saying that, okay, the x-axis needs to be the displacement, and y-axis is, I don't know what this hy, yeah, it's the car fuels
The
efficiency.
fuel efficiency.
Yeah. I think displacement is yeah, engine size, yeah, in liters, sorry. So yeah, this is how you're representing it. On the x-axis, it is the size of the engine, and the y-axis, it is the fuel efficiency, right? And it is quite simple, and it's very easily it is created this plot for you. And imagine that if you want the same plot, but instead of the engine size, if you want the number of cylinders, CLY, on the x-axis, all you need to do is change this x-axis DISPL into CLY, and everything else remains the same. Right? So learning this grammar to, it is like any other language, right? Because you're learning R, it's a new language you need to learn. You also need to learn the grammar of things. Otherwise, if I just tell you 6-7 random words, like the first thing I learn in any language is the bad words, right? Because I don't want people to call me bad words. So I try to remember those. But it invariably, that is not going to help me. The only thing that is going to help me is if I know the vocabulary, if I know the grammar of how that language sentences are made and things like that. Right? Similarly, you need to understand the grammar first. So the grammar starts like this. You take the data set, then you call the ggplot function, then you add the geometry. And there'll be any number of geometries that, like last time also we've seen, there are any number of geometries that are there. But within that geometries, you need to specify, okay, what is my x-axis going to be? What is my y-axis going to be? What is my color going to be? What, for example, for this geom point, is there any aesthetics I can give for the size of the point? For example, the faster the car goes, the bigger the size should be. All that is possible as long as you put it in the aesthetics part and you think about it, right? So this grammar, what it helps you is that it creates a mental template for you, and it forces you to think, okay, now if I change this variable, if I tweak this variable, if I put this graph side by side, are they going to give me any kind of influence? Right? We'll go through this chapter, and then in the end we'll do some exercises within this chapter. Okay. So the template goes like this. The ggplot, we already talked about this. You say data equals to, and then you can just say data, whatever the data is. And then the geometry function. This geometry function can be n number of things. It can be geom underscore point. It can be geom underscore box plot. It can be geom underscore histogram. It can be geom underscore ridge plot. It can be geom underscore scatter plot. It could be geom underscore 3D scatter plot. It can be any number of things, right? But what you need to give within this geom is the mappings. And it could be possible that you can have you all know this interesting graph, right? You have a scatter plot and then you have a regression line, right? So you can break it down that, okay, this is my data set. First, I will be saying geom underscore point and give the points. And then plus I will say geom underscore line. And then I will say, okay, this line needs to be the logistic model or a linear regression model or whatever. And then, but this should go in the mappings, right? So we'll see how to do all of that. So I think these exercises are, I'm very sure that you guys will be able to do it with your eyes closed, right? Yeah. So in case of mapping, you can also change the shape and size of things. You can specify that, for example, you can say a certain number of threshold of things can be red color, anything that has, you can color these by Audi or, BMW or, Mustang or Ford or whatever, right? the companies can be used to color these graphs, points as well. That goes into the aesthetics. Like color is class, right? The class is again two-seater, compact, mid-size, minivan, pickup, compact, SUV. All these, and you just had to add this simple line, right? Okay. Similarly, the size of the point, if you want to change based on whatever. Here we have used class, but you can definitely use the speed or anything. So all you need to do is you just specify, okay, these are my aesthetics. I need to add one more aesthetic, and the size is so and so. Am I being clear?
Yes, sir.
Okay. No, I
Yes, sir.
I'll keep asking you this because of the internet issues and things. So wherever I ask, just please respond. Okay. So there are other things also. For example, sometimes there'll be too many things cluttered, right? You don't want that to happen. You would like to say, okay, you can set the transparency. You can say that, okay, if something value is too low, then I don't want that to be very evident. Okay. But if things are high, I would like that to be more evident. So you can say that okay, transparency is set by this value, whatever it is. If it is low, then you set less. If it is more, then you set it as high. And the transparency set by this alpha aspect, right? Alpha controls the transparency, and you can also set this shape of the points as well. If you see here clearly, the two-seater is given as a circle, compact is a triangle, square is a mid-size, plus sign is a minivan, some other thing is a pickup, and asterisks is a compact and SUV and whatever. Okay. So, but if you see here in this, you're saying ggplot data is MPG plus geom point mapping is aesthetics X and Y. This much you understand. But here, when I say color equals to blue, everything is becoming blue. If you go above and see, the color is equal to class, everything is being set as different class. Okay. But one thing I'd like to point out is that look at this function AES. Okay. The bracket close, open and bracket close. This class is coming within this bracket, isn't it? That is why it understands that it is an aesthetic or it is a mapping. Okay, it's in the aesthetic. But whereas if you come here, this color is put outside this bracket. So it means that, okay, don't map this to anything. Just ensure that whatever point is there, make its color as blue. Okay. So that is how and whatever I'm speaking is actually written here. If you want, you can go through this. It goes outside of it, so they can. Everything is actually clearly mentioned here, but I'm just trying to save some time by going through. So you can change the size of the color, the alpha of the color, and all other things. The shape and all of this is possible. This is a very quick guide on how shapes are. If you put shape equals to 0, like for example, if we put color is equal to blue, right? You can just put a comma here and say shape equals to 1. Then you would have a circle, which is non-filled, empty circle. If you put shape equals to 0, it will be an empty square. But if you want a filled square or red square, all of that, you just have this. And this is always available with you. There are ways. Yes, Google this shape chart ggplot, you'll get this. It's all available. And one other thing is that I think last time it was Lokesh who asked me that when I did color equals to something, and it gave the outline.
Border.
Yeah, the border of it was actually just colored, not the inside. And then he was asking, okay, how to do the insides of it. Then it's not rocket science. It's just simple English. If you want to fill anything by color, just say fill equals to something. So color means the border, fill means inside. Okay, is that clear? So this are colors, these are fills. Okay. 15 to 22 or 23, 24 are fills. Okay. Okay. One other thing is that there are some things that can go wrong as well. Here you wanted the color to be blue, isn't it? I mean, that's what he wanted, but it showed out to be red, and the color has been added as a legend with the word blue. Why did this happen? This happened because by mistake, the color blue, which is supposed to be outside the mapping, or it's not supposed to be part of the aesthetics, but it is supposed to be parts of the geom point as it is. If you put it inside, it is going to consider, okay, you mean that there is something called as blue, and you want to color it, and then let me color it by the thing that it is colored with, the first one, the red color, and I'll name it as blue. There are ways you can tweak things, right? You can say that, okay, this, I don't want to confuse you, but I just wanted to show you that what if you put this inside the bracket, how it will look. Okay? We'll not go to the common problems. I just want to stress on one thing, the facets part. So if you remember, yeah, this part is that color equals to class, and then all this is being colored by class. But what if you want separate plots for each class? For example, for each district, you want separate plot. For each state, you want separately, or for each age group, you want separately. So there is a way you can have separate plots, but within the single, frame. That is called facet. Different facets of things, right? So that is called a facet plot. The way you write it is very, again, intuitive, very easy. It's not very difficult. You just say, okay, take my data set, create a point, geometry with the aesthetics of X is displacement and Y is the fuel efficiency, and create a facet wrap with 2 rows with class variable as the indicator. So it creates 2 rows, and the class variable was 2-seater, compact, mid-size, minivan, and all of that, and then all of that it made it separately. And so this is one easy way to create a facet. The facet has 2 other. The facet function has 2 other variants. Yeah, I would. Yeah, I think it's a good enough way to say it, a variant. There is facet wrap and facet grid. So whenever you have 2 variables, you would like to have a grid of things, right? On my x-axis, on my columns, why don't you put it as class? Whereas on my rows, you put it as the type of the company, Audi or BMW. So for that, you would use the facet grid. But the input for if you see, for the facet wrap, the syntax is a little different. You use this tilde, useless in other cases. Other than R, very less we use this approximation or tilde symbol, right? So this is a formula. In R, this is how we write formulas as. So we say that, okay, this and this. DRV is the, what was DRV? DRV was the number of cylinders, is it? Yeah, 4-wheel drive or whatever. I'm not sure. 4FR. Anyway, what it's trying to say is that the difference between facet wrap and facet grid is that in the facet wrap, you have the columns as the class. Whereas in facet grid, you can give 2 things. You can say, okay, my cylinder is my rows and my columns is some other thing. We'll look at all of that. And there are a number of things that you can do with it. This is one other example. For example, this is the scatter plot we were talking about, and this is the linear regression or smooth exponential smoothing, lowest smoothing of this. This is a statistical approximation of the this scatter plot, right? So what it means is that, okay, as the this engine size is around 5 cylinders, the fuel efficiency goes down. Okay, but after 5, it increases. The efficiency increases. That is what it's trying to say. So if you actually try to do a linear representation of this, it would just be a single line like this, somewhere around here. But since you're actually doing a smooth line, splines, it uses lowest LOWESS, lowest approximation. It's doing a spline correction, cubic spline correction, and it is giving you a more smoother representation of how things go. By just looking at the left side scatter plot, it will be very difficult to guess how relationships change, right? It looks very linear as of right now. But here, what it is representing, not just the blue line, but it's also representing a shaded line, right? Shaded line, or we call it a ribbon. Right? The ribbon here represents the 95% confidence interval. There are any number of other things you can do. I don't want to, there are line types also. For example, this, geom smooth is actually. So one way is that you can just press on any of this. It's going to open the reference. Smooth conditional means. So it is going to use, geom smooth is actually using the lowest correction, if I'm not wrong, method. Yeah, there is logistic regression, linear regression, general linear models, general additive models, and lowest. Okay. And then what is the default? Yeah, geom smooth. Yeah, stat is smooth. Yeah. So it gives you the smooth option. So when it says stat smooth, it actually goes to the lowest option. Yeah, anyway. So this is an example of it. So you're saying, okay, it's very easy to read this, right? You're not saying data equals to MPG. It is inherently understood. The first argument and only argument it takes is MPG. But if you see the aesthetics here, it's actually taken, earlier it used to be in the point geometry. You can bring it up also. One good thing is that you can actually take the aesthetics from each of the geometry layers and place it in the ggplot layer as well. That means that this is set. For everything that is followed, the x-axis should be displacement and y-axis should be the fuel efficiency. You're getting my point?
Sir, can you repeat this once again?
Okay. So
This-
if you
this
remember,
part.
for everything that we talked about, the aesthetics, the mapping, which we talked about, x-axis should be this, y-axis should be this. Earlier, it was put in the geom point function, isn't it? Color equals to blue, isn't it? Earlier, it was in
Yes,
the
sir, yes.
geom point. But we can do this, we can put this aesthetics also in the ggplot thing. What that would mean is anything that follows after this is actually going to take the x-axis as displacement and y-axis as fuel efficiency. Okay. So for geom point and geom smooth, the x-axis and y-axis are already specified here. So you can give empty arguments here. It doesn't matter. Am I making sense?
Okay, okay, sir. Yes.
And if you see this plot would only give you the scatter plot, but you're adding plus geom smooth, so everything is overlapped now, right? So this is helpful. You're actually creating a regression line, a smooth regression line, just by specifying your x and y and just adding two empty functions here. We'll see that. But I'm just trying to tell you the different ways you can do it. There are ways you can change the orientation also, and a number of things is also possible. And you can specify, okay, what the span needs to be and things like that. But let us go back to the ggplot later. So you can specify the color as of the line as usual. You can have different facets also. So this is what it was. If you remember, see, this is exactly the same plot we saw before. Yes or no? Isn't it?
Yes. Yes.
Yeah. But if you see, we are repeating this function. Now we are saying that mapping equals to aesthetics equals to x equals to displacement, y is this. And here also we are repeating the same. Instead of this, if we just copy this and put it on top with the ggplot, then it is inherently understood that for whatever that follows, the x is displacement and y is the the fuel efficiency, and it gives us the same plot. Am I clear, or am I confusing you?
No, sir, it is clear.
It's not clear, is it?
It is clear, sir.
Okay. Let's move
Clear.
forward. So all this is possible. Like you mentioned here only the aesthetics of x and y, just like before. But you have option of adding additional mapping. Yeah. Here you have added just the color. For the points, I want the color to be by class. That's also possible. You can also say I want the color to be for smoothing also to be by class. Then it will make like 7 or 8 different graphs and the lines, and it will try to do that. So here you are saying that I'm using the filter option. Just I want the smoothing line to be for the class of subcompact, right? So it's only doing for the subcompact. See, this is nothing but the same functions we have used. Now, what are the functions we have used before? Can you recollect all the verbs, dplyr verbs?
Filter, select, mutate.
Filter, select, mutate, arrange, summarize, group by, isn't it? Arrange, those only, no?
Yes.
Distinct, count, and
Unique.
yeah, unique, distinct, count. Yeah, it is. I told you, right? The 80-20 rule. 80% of the work happens by 20% of things. But here it is 95 and 0.5%. Just 0.5% of the functions are required for you to do much of all the work that you want to do. Okay. You learn how filter works, and yeah, I think you already done that. There are a couple of exercises. Okay. Can you anticipate this fifth exercise? Will these two graphs look different? Why or why not? The first one and the second one. I'll give you 30 seconds maybe to tell yes or no.
They should look the same, sir.
It should look the
It
same.
should be the same, sir.
I agree. Yeah.
Same.
Why? The second part of the question.
It's taking the same for x-axis and y-axis, like
Yeah.
like both the commands.
Correct. And what about the fourth question? Okay, let us come back here. Now, when it says SC equals to false in this, it is just a line, no more ribbon, right? The ribbon was here, no, earlier. Here, ribbon was not there. The standard errors or the confidence intervals will not be represented if we say SC equals to false. And this is all there in the documentation. You see, SC, if you go and look in the SC, displays the confidence interval around smooth, true by default, C level to control. Okay, level by default, it is 95% confidence. That is what we traditionally use. Nah? So all of these are inherent. If you want to change it to 80% or 99%, you just say SE equals to true. Or if you just say level equals to 0.99, then 99%. Am I making sense?
Yes, sir.
Okay.
Yes, sir.
Yeah, these are all busy slides, but this is very quickly you can do all of this. They are using a new dataset diamond, which is also inherent. This is having information about 54,000 diamonds, right? And this is all real dataset. It includes price, the carat, color, clarity, and cut of each diamond. And this chart shows that more diamonds are available with high quality cuts than low quality cuts, isn't it? So you're saying take this diamonds data set, which is having 54,000 diamonds data, and you're saying X is cut. So X axis is fair, good, very good, premium, ideal. So it says that, okay, if more data, much of the diamonds are of good quality than low or fair quality, better quality than good quality. Yeah, there are a number of things. This is what they're trying to do. What actually happens is that this data set is actually there in this, how do I say? Did you mention that you have to count the data before you plot it? You have not mentioned it anywhere, no? You said just the data set is diamonds.
Yes.
And you said create a bar chart and X has to be the cut, the type of cut. You did not mention that, summarize it and, make it N is the count and thing. You did not do all of that. But it still did it for you. The reason is it took this data, and when you say geom bar, it already understands. Okay, when you say geom bar, you're giving the data in a tidy format. I need to estimate the count of each, so it is going to use the stat count function within itself. Where is that? Yeah, stat count function, and stat count is nothing but it is actually creating a column. So it's creating a summary table for you, isn't it? By the type, the count, and the proportion. And then it is saying that, okay, x-axis is count, y-axis is the cut, and it is creating it for you. Okay. So much of the things that you actually do in your tabular summarization need not be done here. If you remember earlier, when we were using the GATS, what global tobacco adult use survey, whatever. We were using that data set, but that was a summary, it was giving us a percentage of things. It is not the individuals, number of individuals it is giving us. So then we have to say that stat equals to identity, right? That means that we have already made the counts. Now you take no need to transform it or no need to use stat count function. We have already summarized it for you. Now you prepare it for me. Yeah, that's also possible. So for example, this is the data set we had last time. Here we say stat equals to identity. So it understands that, okay, I need not do this transformation which I did before. I just need to take these numbers and plot it. Am I clear? Or do you want me to repeat the last point?
Can you repeat the last point?
Okay. So you can have data in two formats, right? You can have the raw data, you can have the summarized data, isn't it? So for example,
Yes.
you can have 54,000 rows and each of it saying fair, good, very good, premium, ideal, right? You can have 1,610 rows saying fair. You can have 49,006 saying good, whatever. So total of 54,000. Or you can just have these 5 rows with the frequencies. This is a summary table, right? Whenever you take this data set and say count cut, this is what you'll get it. Isn't it?
sir.
Yes.
Okay. I think I'll make it more clear when we move to R. Okay? But yeah, so instead of having 54,000 rows, here you are only having 5 rows. And this is a summary of this data. Now, when you're just giving it the summary, you can just tell it that, okay, I don't want you to do the stat count thing. Okay. I don't want you to do the stat count thing. I am already giving you the identity of what you need to put it as the bar. So this is what happens. Is it clear?
Okay, sir.
Yes, sir.
And it is possible that, okay, I don't want you to put it this way. I want the proportion. Then you can say stat is prop, and you can say each of them are each groups. And then it says that, okay, 40% are ideal, 25 to 26% are premium. So all of this. So you need not do the calculation again. You can just say that stat is prop. Am I clear?
Yes, sir.
Yes, sir.
I think you'll get the hang of it later on. No? Yeah, I don't want you to go into this stat summary thing because it's a little difficult to understand right away for the first timers. But there are other options where you can do all this. This is what we were talking about. No, color and fill. What is the difference? The first one is color because only the outline is given as different colors. Now, when you say fill, everything is filled. Okay, great. You can also give any other value, and then you can say that, okay, it needs to be done that. But if you see, you can give the we'll come to this later. Yeah, here alpha is being used. Alpha of 1 by 5, 20%. So everything is transparency is set to 20%. And here you're saying fill is NA, so nothing is filled here. Only the color is clarity. Only the outline is being filled. Whereas inside you are not saying earlier. If you don't say fill equals to NA, it is actually giving you the gray or a black kind of bar, right? But if you say fill equals to NA, then it will say that, okay, let me not color anything. I'll just put only the outline of it. Okay. These are all options, and the more you use it, the more you will understand it. But let me tell you that the ggplot is very powerful, in the sense that it creates very quick and easy plots, and there are ways to save it and all of that very easily. You can do things like that. But there are some limitations to it in terms of there might not, because it's a static plot, right? There's not a lot of interactivity available. But there are plugins for it, and there are ways you can. There are extensions to ggplots as well. I'll just very quickly show you. So this is a very good, place where if you want, you can come. So this is patchwork. Patchwork allows you to, keep multiple plots in one single framework. You can say this is my first ggplot. Is this visible to you? Is this visible?
Yes,
Yes.
sir.
Okay. You can say this is my first plot. This is my second plot. Okay. And you can say library patchwork, and you can just add both of them, and then they'll be side by side. Or you can, specify your layout saying that first plot, second plot, third plot, and this is my fourth plot, right? First 2, 3, you put it side by side, and then you put a fourth plot below. So there are any number of things you can do with patchwork. I'll not go into that, but that is an extension. There is a very interesting GG animate extension. It allows you to have all these animated plots. You're able to see? है ना? This is again the gap-minder dataset, GDP per capita dataset. By year, we can see things moving. Is it clear? Yeah, one number of other things, and I'm not going to get into there. If you are interested in your output being like SPSS or Stata, that is also possible by this GG themes, extension. If you want, and there are other ways to. There are very, very, very interesting extensions to ggplot. One of my favorite is GG Ridges. This survival plots. It's very easy to create this Kaplan-Meier curves and things. Then you have this contours. GG radar is there. Time series. Yeah, I will not go into more details, but yeah, tidy terra is there. This is one example with the horizon plot. And use satellite data to create your horizon plots. And all of this is based on, if you see, everything is GG. Earlier, if you saw a tidyverse, everything, I mean, just the tidyverse extensions had tidy something, right? Tidy base. Last time we talked, no, tidy base, tidy. Let me just very quickly. Yeah, tidy. Yeah, there are a lot of tidy things. See, tidy base, tidy geocode, tidy graphs, tidy model, tidy select, tidy terra, tidy text. All of this is available. Just like that, everything GG Muller, GG heat map, GG miscellaneous, GG shadow, flow charts you can create, timelines, Gantt charts, n number of things you can create. Okay. And all of this is based on the same grammar of graphics. Same thing. Nothing is going to change. It is still going to be ggplot something plus geom something geom underscore something plus facet or whatever. Okay. I think we can move on to the. Yeah, I think this much we can stop now. No? I think we have covered this chapter almost. No? Am I audible?
Yes, sir.
Yes.
Yes, sir.
Oh,
Yes.
I
Yes,
had
sir.
a internet, power cut here, but luckily I'm using my mobile phone internet. You're still able to see my screen, right?
Yes.
Yes,
sir.
sir.
My laptop might get slow, but let me. I'll start a new session, new project. Existing directory. What did I just do? I just created a project in the existing folder like every time. Oh. Am I audible?
Sir.
Yeah. Forgive me if my computer will turn off because there's not much battery here, but I'll try to do the best that we can. Huh? So data visualization. Okay. So what is the package? ggplot. Load packages. What is the package name?
ggplot2.
ggplot2, isn't it? The moment I run ggplot2, it's loaded. So I will take a data set which is already inbuilt. Let us use the empty cars data set. Or do you want to use some other data set also? It is fine. Empty cars. Okay, I'll say empty cars is there. So in my environment, there is a new data set, which is 32 rows. If you want, I can just use the diamonds data set. Let us use the diamonds data set. Diamonds data set, around 54,000 rows. So what is the very quick way to look at the data set? Glimpse, df pipe glimpse. Glimpse. So it says that there is no pipe function. You would not really think as pipe as function, but pipe is a function which is coming from the tidyverse package. No? So that is why it's always good instead of loading this individual ggplot, individual per or individually readr and things like that table. You just load tidyverse, which loads everything for you. See, 1, 2, 3, 4, 5, 6, 7 is loaded. The reason is it ggplot we have already loaded. Okay? So it does not load things unnecessarily also. Now we are taking this, saying looking at glimpse. So it says caret is a double, cut is an ordinal variable. Earlier we have not seen this, right? We have only looked at factors, but ordered factors are also there. So cut is a factor. So for example, if I say df dollar, if I say df dollar, everything that is all the variables that are there for df is now available for me. So I can just say, okay, cut, which I know from my console that it is an ordinal, but I can just hit Control Enter, and then it will say, okay, this is all this. So levels, you see the levels are now fair is less than good, is less than very good, is less than premium, is less than ideal, isn't it? So if I just want to plot the cut, I can just say df pipe ggplot ggplot plus. It is not pipe now, it is plus geo bar. Then I can say AES x equals to cut, isn't it? So it is going to create a bar chart for me. This is what we have done previously, isn't it? Yes or no?
Yes, sir.
Okay. So now the same thing, but if I want, let me look at all the other variables that are available for me now. Caret. What is caret? Caret is this thing. Let me look at one ordinal variable if I can. Yeah. Let me think color. Let us look at what is color. Color is given in these symbols. I think this is the. Let us look at the data set itself. I'll just press F1. I'll go to diamonds and press F1, and then it will open the prices of over 5,000 round cut diamonds. So price is dollars, carats, weight of the thing, cut, color. Color is D is the best and J is the worst. Okay. Yeah, but then we have the orders reversed, isn't it? Yes or no?
Yes.
Yes,
Isn't
sir.
it? Orders are reversed, no? So we have to be very careful, even though this data set is there online, but you have to also look at the documentation to actually understand. So instead of saying DF color, what if I say a reverse of DF color? Sorry, so capitals. Okay, I can say take this df, mutate color reverse equals to factor of color, but levels equals to reverse of full So now you see what happened. See, D is the best. So D is the best. J is the worst. So J is the worst. Am I audible?
Yes, sir.
Yes,
Do you want to know what I did?
Yes, sir. The
Yeah,
command you
this
had
line I'll
given.
explain. Okay. So what I did was I very quickly created a new variable. Okay. The variable name was color underscore ref. And I know that it's a factor. So for example, if I just type df dollar color and pipe it and say factor, it will say yes, it's a factor, and these are the levels, or I can just say levels. Levels. Because it's an ordinal variable, these are the levels. But I want to say that this is not the levels. I need to reverse these levels. So if I can just say reverse these, ref is the function for reversing things, right? See what happened? Am I audible?
Yes, sir.
Yes, sir. Yes.
Okay. Okay.
Reverse.
Yes, sir.
So I can just say take. I can just say factor of df dollar color this is how it is. Then I can specify what my colors needs to be or my levels needs to be. Here my levels are, I have reversed this. So I can just say call this itself as a variable. I can call this as reverse labels. Okay. Actually, it has to be reverse levels. Okay. When I look at reverse levels, this is what it is. So I can say factor this, and but now levels are the reverse of levels. So all this I have done in a single line here. Okay. I said that, okay, create a new variable called color reverse, and the color reverse needs to be a factor of colors, but the levels needs to be the reverse of levels. Okay. That is nothing but this. This and this is same. Okay. Am I clear?
Yes, sir.
So
Sir,
this is the
one
norm. Yeah, please.
Sir, why did it like automatically choose like the other way? Like when it's actually written like J is the best, I mean, in the data
Yeah,
set, like.
I think it did not automatically choose. There is an error that it is said that it is an ordinal variable, but maybe not many people looked at it properly.
Yes.
Could be that, because you take things for granted, right? You take okay, this is just a data set, it is there and things, but only when you look at the documentation and this, only then it makes sense. Okay.
Okay.
Okay. The point being, now that we have created a new variable, this won't work unless and until we reassign it. No, this is what we have to do now, isn't it? Correct?
Yes, sir. Yes, sir.
Okay. So now if I say color it by, if I want to color it by, color equals to color, I'll just run these two things again and again and color reverse, right? So this is going to create a plot for you. Okay. What would be the better thing? Instead of color, I should give
Fill.
fill. So I'll give it fill here. So if you see, the color combination is from D to J. Light is J and D is dark. But here J is dark and D is light. So it's totally up to you how you want to represent it. But it's always good to go through the documentation as well. This I did not expect, and I have not planned it this way. But just by looking at it, we could realize that there is some mistake, and we could be able to, rectify it. So I would also like you to look at clarity. Then you tell me how to do the same kind of exercise for clarity, in the sense that I want you to have a look. Okay, you need to tell me what I need to type. Okay, I want to just look at just like we looked at color and rectified it. I want to look at clarity, and if there is a need to rectify it, I'll have to rectify it. Now you tell me what is the code for it. Okay, fair enough?
Okay, sir.
Okay, now tell me, line number 27, what I need to type?
DF dollar clarity.
DF dollar clarity. Okay, so clarity, it's saying that the best clarity is IX and the worst clarity is I1, isn't it?
Yes, sir.
Let us look at I think clarity is written correctly.
Yeah, clarity is written right.
Okay, great. Fine. Okay. Now, let us look at one other thing. Okay, I want to see whether clarity is good, color is good, carrots are good, or I want to see what is actually influencing the price. Okay, which of the diamonds have higher price, isn't it? Are you getting my point?
Yes, sir.
Yes, sir.
Okay. Okay. Let us plot the price first. Okay. Will that be fine? Price,
Yes, sir.
price by the carrots. Will that be okay?
Yes, sir.
Okay. You want the price to be on the x-axis or the y-axis?
Y-axis.
Okay.
Axis.
You want y to be price, and sorry. You want y to be the price and x to be
Carrot here.
Carrot.
carrot, right? So now you tell me, okay, carrot. Okay. So you tell me how to do it. Just like you told me for the previous one. So I should take DF, is it?
Yes, sir.
DF,
And you can check.
you want me to check once, is it? Carrot. Carrot is a class. It's a numeric. Price, you want to check price. Price. It's an integer. Okay, that's fine. Both are integers. So tell me one thing. These are all, again, fundamental things. There's no point in asking you guys this, but both the variables are numerics, isn't it? So what is the most appropriate plot for two continuous variables? Am I stuck?
Hello.
Yeah, okay.
Yes, sir.
Yeah. What is the most appropriate plot for two continuous variables? Can I have a bar chart?
No, sir. Bar chart won't be proper. It should be a correlation between these two.
Okay, you're going. Okay, I would agree with you. So simple scatter plot should do, no?
Okay. Yes, sir. Scatter plot.
Yeah, that is the word you're looking for, right?
Yes, sir.
Scatter plot. How many of
Yes,
you have
sir.
come across this word scatter plot?
Yes, sir. Scatter plot and line diagram will also do.
Okay, you want to do a line diagram. Line from where? Okay, I'll tell you. Okay, first let us look at scatter, and then let us look at line. Okay, I agree with you to an extent, but you need to substantiate your argument also. Okay. Let us do a scatter plot first. We'll take a data frame. Okay, so what is the syntax for a ggplot?
ggplot,
Ggplot, isn't it?
ggplot. Yes, sir.
Okay, then you need geometry.
Geo-
है ना? So what do you want? Geo?
Character.
Yeah, you can say scatter is not geom underscore scatter is not there, but we'll say points. Geom point is the syntax for it. Okay. Then we'll say aesthetics. X equals to what should be your x-axis? Caret, no?
Caret.
Y is equal to price. Isn't
Price.
it? Isn't it?
Yes, sir.
Okay, great, excellent. It's taking some time because it has to do 50,000 rows of things, points of things.
Oh.
You see?
Sir.
Okay, great. So yeah, you know that, okay, as the carrots are increasing, price is also increasing. Okay.
Yes, sir. Yes, sir.
However, there are some things that are more costly. See, this 1 carat diamond is more costly than this 4
3
carat.
carat. 4
Yeah,
carat. Yes,
3
sir.
or 4 carat diamond. Huh?
Yes, sir.
So though there is a relationship between carat and price, this relationship may not be linear.
Yes, sir.
Do you agree?
Yes, sir.
Yes,
Okay.
sir.
Okay. So we came up with the first question, right? See, I'm trying to bring you down to this, crystallization of this EDA principle, right? The number of questions you need to ask has to be more, right? The first question you
Yes.
asked was, okay, what is the relationship between carat and price? My hypothesis was that the more the carats are, the price is also high. And yeah, to an extent it is true, but there are instances where it is not true as well, isn't it?
Yes, sir.
So do you think we need to investigate this further?
Yes, sir.
Yes, sir.
Okay. Okay. We'll park that investigation now, but now let us look at line diagram. Yeah. So how do you want the line to be, Subarna?
Yes, sir.
Yeah, when you said line diagram,
Yes, sir.
so what do you want the line to be? How do you want the line to be? The x-axis and y-axis is fine. So where does the line come here? So if I say, okay, I'll just do one thing. I'll just copy this. Instead of geom point, I'll put geom line. Okay. And let's see what's happening. Isn't it, Subarna?
Yes, sir. Yes, sir. Yes, sir.
Okay, this is what you're saying, isn't it?
Yes, sir. But it
Yeah.
not look good.
It's not about looking good. It's about how
Yes,
you're
but
interpreting it.
We
difficult
cannot
to interpret.
it.
Yes.
Difficult to interpret.
So
That's why I'm saying.
it's simple things needs to be there, and you need to think about things. Huh? See, you thought line diagram will do good, but you were able to test it also with just one 4-letter change, right?
Yes, sir.
And then you realize, no, this doesn't really make sense. And then you realize now that for every 2 variables where they are continuous variables, a scatter plot is the best one. Line diagram is not really a good choice, isn't it?
Yes, sir.
That fundamentals are clear now.
Yes.
Yes, sir.
And I'll give you a resource to what kind of plots to do for what variables and all. But that again is like that big, what do you call it? That flow chart, right? When you say, okay, 2 means, then this one is categorical, then that. All that is fine. Okay. But things don't really make sense unless until you actually have some background understanding as well. Okay, let us go further. let us go. I'll try to remove this. I'll keep this here because I'll be sharing this code with you guys. Okay, where should I? Let me first save this. Where do I save this?
Save button.
What?
You
Where
can
do I
save.
save
It's
this?
already
I'll save this in a folder called code, isn't it?
code. Yes, sir.
Right. So what should I save it as? Visualization data.
Sure.
Viz. Okay. For now. Okay. Oh, DAO is system. We rename it. Okay. Fine. So this is what we need to reinvestigate, right?
Yes, sir. The scattered plot.
This one. Okay. So now what is your next hypothesis? We now know that carrot is not the only thing that is driving the price up. Do you think clarity also might influence the price?
Something else is also influenced.
Okay. Okay. Now what are those other things? Let us look at this glimpse once again, or we can go to this help menu. Say carrot cut. Okay, cut might be no, because it is a. Let us look at cut. Okay.
Yes.
Okay.
Cut is
Now-
also important, sir.
Okay. Hmm.
But everything that has that ordinal might be influenced.
Okay,
Because there is best to
Okay, fine. In that case, let us look at all the ordinal variables. Huh? Cut, color, then clarity, then
Depth.
depth. Depth is
No,
not
no, sir.
ordinal. No?
Depth is a continuous variable.
Okay. Okay. I'll say color reverse. Is that okay with you guys?
Yes, sir.
Yes.
Okay.
Okay.
Great.
Okay.
Okay, fine. So we'll take this plot and then we'll add cut. How do I add cut? Cut. I'll just say color equals to cut. I'm adding it within the aesthetics, huh? Have you noticed?
Sir.
Yes.
Okay.
Oh,
Say, very
okay.
busy, no? Very busy, isn't it? Very busy.
Yes, sir.
Yes, sir.
Yes, sir.
I'll add alpha. Okay, alpha. I'll just make all these plots transparent by 50%. Okay, 0.5%. 0.5 means 50%.
Okay.
Okay, there are two things that's happening very evidently, na? That all the yellows are tending to be on top and all the darker colors are tending to be on the down,
Yes.
Yes, sir.
isn't it? So in
Yes.
every, it's evident that, okay, if carrot is, irrespective of the carrot, yes, carrot also has some value, but if the cut is fair, ideal, then the cost is higher. And it is
Yes, sir.
exponentially higher. Okay. But you see, there is an yellow dot here, there is an yellow dot here, yellow dot here, and there is a green dot here. No? So this is an ideal diamond, which has an ideal cut with this carrot 2.5 and price is this much. But the same kind of diamond with the same carrot same carrot but lesser cut is having higher price, isn't it?
Yes, sir.
You get my point? For the same this thing, you are having better cuts lower than the worser cuts or fairer cuts, right? Get my
Yes,
point?
sir.
Yeah.
Yes, sir.
So,
For same carrot.
so now you know it's not just the in fact, that is important. Now we need to look at the relationship between clarity also. Let us add clarity. How do you add clarity?
Maybe as a shape.
Don't add the shape. Using shapes for an ordinary variable is not advised.
Okay.
Yeah, the reason is it really adding any more clarity to this information?
No,
Just worsen things, isn't it?
it's not at all visible now. It's all.
Yes, sir.
Yeah.
Hmm.
So if it were me, what I would have done is I would have added a facet. Okay. Facet wrap by that. It's carried. Yes. Make sense? Now you see. Now what is the difference is that things are getting much more clearer. Okay. Things are getting much more clearer because some things are much more linear, isn't it? The first
Yes,
one, IL is worse, right? IL is worse,
Yes.
no?
Yes.
IF
Yes,
is
sir.
more, right? So this you
Yes,
can
sir.
see it's going from flatter to steeper, isn't it? The
Yes.
relationship. No, I don't
Yes,
know
sir.
if you're able to appreciate it, but I can
Yes,
see
sir.
it.
Yes, sir.
No? It's quite
sir.
evident, isn't it? Okay. We'll do one thing. Let us add one. What I'll do is I'll just take this out. Okay. I'll just take this out. I'll put it on top. And it's still going to be the same. Okay. Let me prove it to you that the plot is not going to change. The plot did not change, no?
No, sir.
Yeah. So if I add Guillaume's mode, now you'll really appreciate, okay, that this is. You can now compare the regression lines, right?
Yes.
Okay. Yes,
Okay.
sir.
See, some regression lines are steeper, some are wiggly, some after a point they taper, some stay the same, isn't it? You get my
Yes,
point?
sir. Yes, sir.
So what does this mean? This means that the relationship between the diamond's price, size, cut, and clarity is non-linear, isn't it?
Yes,
Yes,
sir.
sir.
Oh, fine. Let us add, we missed one color, right? Color is also one thing that we missed. Agree? How would
Yes,
you
sir.
add color here?
Grid.
Sorry?
Sir, you said about a grid where we can add.
Good, great. Means you're paying attention. Color reverse, okay? I'll use reverse. yeah, it's too busy, but let us try to make sense. Things will get steeper. I'll tell you how. It looks very cumbersome and not very helpful, but let us try to understand and interpret it. It will really be interesting. Look at this. So this is the worst kind of diamond that you can have. I mean, I'm not saying it's still a diamond, uh, it's still costing somewhere from, $20,000 or something. But still, you see, the line is a little linear, right?
Yes, sir.
I agree.
Yes, sir.
So, yeah. So you have bigger diamonds here, and you have smaller diamonds here. But you see, the line is a little flat here. You see, I know, I don't know if you're able to appreciate it. It's a line, it's a flat, and as it is going down, it is getting steeper, isn't it? So, for example, a 3.5 carat diamond is $15,000 here, whereas a $3.5 carat diamond is lesser here. I don't know if you're able to see. Okay, let us not go there. Look at this trend. Look at the trend on the, take each row as a single entity. As it is going to the right, it is getting a little steeper. It is like a snake which is standing up, isn't it?
Yes, sir. Yes,
Also,
right.
you go,
It's more.
yeah. If you go from up to down, take a single column. It is also a snake that it is trying to stand up more straight,
Yes.
isn't it?
Yes, sir.
So, on the left top corner, you have a flattest regression line, whereas on the right bottom corner, you have the steepest regression line. Okay.
Yes, sir.
So,
Yes, sir.
as the clarity is the highest, the cut is the highest, the color is the highest, even 1 carat is giving you the same price as the 5 carat diamond here. You get my point?
Okay.
So, yeah, now, because this is again based on mathematics, you can come up with, it is not using a linear model, it is using a smooth model, and within a smooth model also it is specifying that it is using a generalized additive model, and it says that y is dependent on not just x. Y, that is price, is not just dependent on x, it is also dependent on some other thing. BS equals to CS is, it's a covariance matrix. So it's taking cut, clarity, and other things also into account. Okay. So the BS equals to CS is actually covariate. Yeah. Maybe one day, if you guys are up for it, we can go into the generalized additive models and regression workshops and things like that. But understand that these are higher level models. It is not just based on the linear assumptions and logistic assumptions. It's all based on assumptions, but it's an additive model, and additive models are more flexible. It can give you more power in terms of giving what kind, is it a fixed model, is it a random effects model, or is it a mixed effects modeling, things like that. But having said that, you can go from the simple box, what do you call it? The simple, this plot to this in a matter of maybe 5-10 minutes, right?
Yes, sir.
This is the one we started with, right? Yeah,
It
this
is
is the one we
fine.
started.
Yes, sir. Yes.
And we went with this, isn't it?
It's not visible,
Yes.
sir, I think.
Yeah, it'll just take some time to load, but yeah, this is what we have reached. This is what we have reached, isn't it?
Yes, sir.
This one was the earlier box plot, though was simple, it had a lot of hidden information, right?
Yes,
And
sir.
we were able to pick out that information by visualization. You get my point? We were able to say that,
Yes, sir.
okay, though everything looks fine, but there are some things that which is 1 carat also, but was costlier than the 5 carat one. Turns out this 5 carat one has the best clarity, isn't it? It is this one.
Okay.
The
The
best,
right
yeah,
last corner one.
yeah, this one, you know, it has the best clarity, the best color, and the best, everything. But if you would have used the color, not the thing that we did, if you would have done this, we are using the original color that they have given, no? Color variable, not the reverse one that we have created. Let us see, is it telling any other story? It's less meaningful, isn't it? I mean, we have to
Yes.
read it from down to up now. Get my point?
Yes, sir. Yes, sir. Like a reversed one. Further.
From walkie-talkies here, I think I should reduce the. Okay, sorry. So, yeah, the point of today's session was to again dangle the carrot and make you interested in the power of visualization and make you think in such a way that, okay, what works and what, and we have only used one geom. I mean, 2 geoms. We do use the geom point and geom smooth. But there are n number of things that you can do. See, I can just very quickly take the DF and I can say, now I want, let me see what is the average price or median price of by cut itself, price and cut, okay, instead of the carat. So one is a continuous variable and the other is a categorical variable, isn't it? So what will be the best plot to represent one categorical and one continuous variable? Tell me.
A bar chart, categorical variable and
Yeah, bar chart would be for both 2 categorical variables are there.
yeah.
Am I stuck? Hello?
No, sir. It's
Oh, okay.
you're audible.
Okay, it's a box plot.
Box plot.
Okay, I'll tell you why. Okay, this doesn't make much sense. Let me change the orientation. Okay, so our assumption that the price will be higher when the cut is better is wrong. The median price is lower, isn't it? So I hope you guys know how to interpret a box plot.
Yes, sir.
Okay,
Yes,
box
sir.
plot talks about the distribution of the variable. The middle line that you're seeing is the
Median.
median. So it is a middle value, 50th percentile, right? Middle value. And this white thing you're seeing is the middle 50%, means 25 to 75.
75.
So this is the 25th percentile, and this is the 75th percentile. Okay. So if you see, not a lot of variation is there in the pair group, whereas there is quite a bit of variation in the premium group and ideal group, right? Isn't it? The price is not too high here, but now, what if I add one more variable, and maybe not cut? Maybe let us look at clarity. Clarity also doesn't show you a lot of difference, huh? Isn't it? Color is showing you some kind of this thing, isn't it?
Yes, sir.
Yeah. Anyway, there are other ways we can also look at it. We can say color equals to cut. Color. Okay. But then again, instead of color, we can use fill. That's all fine. See, within this SI2, you are able to see an increase in steady increase in price based on its cut, isn't it? Are you looking at this increase, this one?
Yes.
Yes, sir.
But within the I2, it is
But
The
in
I-
the ideal group, the price is lower.
yes. So that means that in this group and the rest of the groups, the cut does not really matter a lot. But when it is the I1 group, the cut really
Cut
matters.
matters. Cut matters.
You get my point?
Yes, sir.
So if I say that cut don't really matter, so it's not that cut doesn't really matter. Cut matters, but not to an extent that maybe only if you remove the ideal ones. Okay, let me be a little this thing here. I'll say filter cut is not equal to. I'm only selecting those where ideal is not there. Huh? Am I making sense?
Yes, sir.
Now look at it. See. You see this median lines, there is a slight increase. Okay, everywhere there is an increase, isn't it?
Yes, sir.
See,
Yes.
at least in the J group, I group, H group, G group, there are some slight increase. But as the clarity is, sorry, DEF is color, no? Yeah,
Yes, sir. Color.
if the color is worse, it is not really going to matter. Okay, but if the color is good, there is a kind of hierarchy, isn't it?
Yes. Yes, sir. In the color
So
group.
here, yeah, at least in the first three colors, there is a hierarchy. But after, if the color is not good enough, then other things might matter. And that other thing might be the carrot.
Okay.
Okay.
Yes, sir.
Sir, can you
Okay,
please repeat it once again?
Okay. I'll make a little more sense. Just one point. Yo. Point y equals. I tried to overlap this thing, but yeah, I think it's because of. Oh, it's what was it? Carrot, no?
Yes, sir.
Okay, what I was trying to do is I was trying to set different x-axis for different things. For example, for the geom point, I want to set clarity as the x-axis, whereas for the box plot, I want to set color reverse as the x-axis. And for everything, I want to set y as the price as the y-axis and fill as the cut. Let's see if it will work. This will definitely be a busy slide, busy plot. Maybe we will have to include ideal. Yeah. Maybe we took too big of a data set for today's exercise. Anyway, while this runs, let us, I think it's almost 6:30. If you guys have any pressing questions, we are going to have the next class on Tuesday, is it?
Yes, sir.
Okay. You guys are available on Tuesday?
Yes, sir.
Yes, sir.
Yes, sir.
Yes,
Okay,
sir.
Tuesday, Wednesday. Okay, fine. I mean, we will take up this exercise a little further in the sense that we will, I'll give you, we'll do a little more formal, what do you call it, hands-on. Okay, I'll let you guys work, and then this is too busy. Carrot is not a good option. Carrot actually is a continuous variable. Facet on carrot should not be a good option. I would definitely. Okay. Yeah. The reason it took so much time is that it is trying to take every decimal point as a category, and it was trying to do it for us. But yeah, this is not a good option. Later on, next time, I'll try to show you how we can add multiple geometries, box plots, the box plots, the point, the line charts, all of that one on top of the other. We can have secondary y-axis and things like that. That will be more meaningful and helpful, I guess. Okay. Can we stop now, or you guys? I'm definitely open to questions if you guys have any. I'll be sharing this like last time. How many of you were able to run the zip folder last time? The project?
Was able to.
You was able to, no?
Yes, sir.
Yes,
I took that and able to run that or to.
Okay.
Yes, sir.
Okay, great. So that's a very nice way of actually sharing projects, right? Just zip a folder and send. Okay. So if you are actually working between yourselves or with anything, or if later on you want to share your project also, you can just work within the project. All the things are there in that. You don't have to worry about sharing the actual files and things like that. Get my point? That was the reason I was insisting on working within the project.
Okay.
Okay.
yes, sir.
Okay, great. What I'll do is I need not send the project today because we are not loading anything else. We are only loading one R script. Okay. So this R script, you can just put it in any project that you have and it should work. Isn't it? Because we are not using here or anything. Correct?
Yes,
We are
sir.
using just the inbuilt text. Okay? I'll just share this R script today. Maybe a couple of more sessions is required on visualization in terms of making you comfortable. So now you're introduced to the structure, at least I guess, right? You're introduced
Yes,
to the structure of things. You're introduced to how taking a data set and how you're actually what do you call it? ggplot and then geometry and aesthetics and facets and all of that. You're now introduced to it. But once I'd like you to practice more and other things like it. You can include multiple data sets. For example, for geom point, you can bring in one more data set. For geom box plot, you can introduce one more data set. All of that is possible. Okay.
Sir, how will we know like how many things are there under this ggplot? I mean, now you said geom point, it represents this like that.
Yeah.
Like
So
box plot is okay, so that is evidence from the name. But
yeah, you can just go to ggplot 2. One good way is to look at the reference. So you have geom AB line, geom H line, geom V line, geom bar, geom call, bin 2D, bin 3D, geom blank, box plot for a box and whisker style of 2 geom contour, 2D contour on a 3D surface, geom count, overlapping points, geom density estimations, dot plot, which will give you this kind of thing, error bars, hexagonal plot, frequency plot, polygon histogram, jitter plot, crossbar, geom map, which will give you a map, geom path, geom point, geom polygon, PQ line, quantile, ribbon, area, rug, segment, smooth, spoke, label, raster, violin, a number of things are there. You can go to extensions and you can forget about whatever I said. Everything is available for you online. It's just that you need to get on, in the sense that if you have a driving license, you will know which is the wiper button, which is the indicator button and things like that. But for that, you have to get a license and sit in the car, no? Enough?
Yes, sir.
Yes, sir. Yes.
Don't worry, see, whatever I'm coming to you is coming from 8 years or 10 years worth of working with an R and ggplot and tidyverse. So things might be overwhelming to you, but I'll tell you once again, but when I started, none of this is available. None of this was available. Everything I had to learn from scratch, trial and error, and banging my head to the wall. Sometimes I'll ask somebody for help online. They'll reply to me after 3 months. Till then, I'll be waiting. All of that will happen. But now things are very available for you. But the challenge is which one to choose. There are a number of things. For example, there are 126 extensions for you. That is only on CRAN. Okay. There are many other things available, but what to choose? Which one to choose? For example, box plot we are talking about. So there is this violin plot here, a number of things here. This is also a dot plot for you, B swarm plot. This is a significance plot. Which one to choose? So, but see, though you have a lot of things in your arsenal, you need to be a little more specific on which tools to choose. So we will give you those. Not the bare minimum. We'll tell you what are the right things. Which one? See, for example, many of these, like Indrajit Patel is there, or some people, are just Thomas is there, Kasambra is there. There are a number of people who actually are working on this a lot, but there are other people also who just come up with very interesting things, and the moment they have a breakup, they are silent for 3 years, 4 years, and all the codes that you have written will not work because our version has changed and nobody has updated that R version, and you're trying to ask him to update it and is not available for you. And then, so it's also important to see which packages to choose, which tools to choose, because you're actually looking for better support. So people who have university, working in university, they are a little more stable, and all that we will not know, right? So when we look at which packages to choose, which one to recommend, we look at the support also behind, and that is when we tell you that use this. Why are we insisting use here? We have used n number of packages, n number of methods to set up this workflow, but out of all of them, here was the best and the easiest, not just for managing things, but also for teaching. So that is what we stick with, and people might find it a little difficult to every time hear and all of that, but that is now it is the industry practice. That is what everybody does. Okay, don't worry about. We'll get to know all of these functions. It is just like, one other way to find out what are all available for you is is just type GEOM. Okay, then all of this is available. Anything you come across, for example, histogram, you just put your cursor on this. It will tell you visualize the distribution of single continuous variable by dividing the x-axis into bins. Okay, for example, jitter. Geom jitter is a convenient shortcut for geom point. Okay, it's called small amount of random variation for each of the points. So it's like I'll just show you the same. Instead of the geom point, I'll use geom jitter. You might not find any difference, but what actually happened was that it made small variations to things that were overlapping, and things that were overlapping were moved aside. Okay, so that crowding has not happened, and things that are falling on top of each other were moved a little further. So all of this happened, and all of these are subtle things that are there, but all of these are available also for you. The moment you type geom_, all of these are available. all that what we talked about are available. GM violin, tile, text, step, smooth, SF. SF is simple features. It's for mapping. Ribbon, rectangle, raster, quantile, QQ anything that you can think of is here. And this is just using the ggplot. There are many extensions and libraries you can still use, like for example, library ggridges, okay, or library gg highlight or horizontal. All these are there. If I just look at this, run this library, and then I say geom underscore, just scroll down, you see GG ridges. It has added 1, 2, 3, 4 different plots. Line density, density ridges, density ridges, and ridges gradient. These 4 different plots have been added to my arsenal now. Now I can use those. For example, if I just look at the help and go to the index and look at the vignettes. See, all these are plots. You get my point?
Yes, sir.
Yes, sir.
Yeah, you'll get used to it. Don't worry.
Okay.
Okay. Anything else?
No.
Okay.
No.
We'll stop now.
Okay, sir.
Okay.
Yes, sir. Thank you, sir.
Okay.
Thank
Okay.
you.
See you on Tuesday then.
Yes.
Yeah, sure.
Yes, sir.
Okay. Again, problem with the internet connection may be there. I'm warning you because I'm in my hometown and it's very difficult to find internet. But I'll try to request the shop again if things don't work out. Take care then. See you on Tuesday. I'll share
Okay,
the
sir.
Okay, sir.
recording and things. I may not be able to upload it with the internet situation, but let's see. At least I'll email you the code. Take care.
Okay.
Bye.
Bye.
Thank you.
Right.